Good day and welcome to our next lesson, 8.4, multiplying monomials and binomials. So let's start with those terms. Are you familiar with the terms monomial, binomial, and trinomial? If not, there are parts of each word that you might know. For example, let's look at the word monomial. Mono, binomial, trinomial. We have three prefixes here, and they each have a meaning. In fact, we see these words elsewhere. For example, monomial, mononucleosis. Somebody has mono, it comes up. Binomial, bicycle. Trinomial, triangle. Okay. So monomial is really talking about one term. Binomial, our prefix bi, two. Trinomial, our prefix would be 3. So today we're going to be multiplying monomials and binomials. Often monomials involve exponents. So let's go over a few things that we've learned previously about exponents. First off, here we have an example, x squared. There are two parts to the expression. The x is what we refer to as a base, and the 2 is what we refer to as a power or an exponent. Okay. Notice the base is larger, the exponent is smaller, and it's written higher up above the base. Now remember, in our previous lesson, we talked about that. So what that exponent is doing, it's telling us how many times to multiply by that base by itself. So if I have something like y cubed, that means I'm saying y times y times y. So I'm taking the base of y and multiplying it by itself 3 times. Likewise, on example C, if I have an xy squared, now notice only the y is raised to the second power. X, there isn't an exponent written, so therefore it's a 1. If there's no exponent written, it's a 1. So that's saying multiply x by itself 1 time, but then multiply y by itself 2 times. Letter D, we have x squared y to the 4th, so we're multiplying x twice, and we're multiplying y by itself 4 times. Okay. So let's see if we can simplify some expressions where we're doing some multiplication. So let's think about this for a second. If I have y cubed times y to the 5th, that's like saying y times itself 3 times and y times itself 5 times. 1, 2, 3, 4, 5. So here's my y multiplied by itself 3 times. And here's y multiplied by itself 5 times. Now if I want to figure out what the whole thing multiplies, totals, let's see how many y's there are total. 1, 2, 3, 4, 5, 6, 7, 8. So we get a total of y to the 8th. Let's see here. I'm thinking I see a pattern, but let's see if we can figure it out on our next example. X to the 4th times x squared. So we've got 4 x's multiplied. 1, 2, 3, 4. So there's my 4. Then I've got to multiply it by itself 2 times. 1, 2. So let's see how many total. I've got 1, 2, 3, 4, 5, 6. So I've got x to the 6th. So in our first case, y cubed, y to the 5th, we total it up, we get 8 of them. 8, so we have y to the 8th. Here we have x to the 4th, x squared, total x to the 6th. Are you seeing a pattern? I think I'm seeing a pattern. Let's look at our third example. Now again, remember, if there is no exponent, it's b to the 1st. So I've got a b to the 1st times 2 of them. So how many total do we have? 3. So do we see a pattern? In our first example A, we had 3 and 5 for a total of 8. In our second example, we had 4 and 2 for a total of 6. And in our third example, we have 1 and 2 for a total of 3. Do you see the pattern? I do. So our rule says that anytime we multiply, you're going to add the exponents, but the key is that the base has to be the same. And a to the m power times a to the n power equals a to the sum. We add the exponents together, m and n add together. So let's look at our examples. So here we have m third, m to the 5th, and m, which is really m to the 1st. They're all the same base, m. So we keep our base, but we add those exponents, 3 and 5 and 1. We add the exponents, so we get a total of 9. So we get m to the 9th power. Now let's look at letter B. This one's a little bit harder. We have b to the 2nd times p, and then b times p cubed. Let's rewrite this. So we've got b squared, we've got p, I'm going to write that as p to the 1st. We have b, again I'll write that as b to the 1st, and then p cubed. So again, we have to watch our bases. So let's look. We've got a b squared and a b to the 1st. We'll combine our like terms. B squared and b to the 1st, same base, add the exponents, 2 plus 1 is 3. Then I'll do the same thing with my p's. We have p to the 1st and p cubed. Same base, add the exponents, we get p to the 4th. Okay, let's do a couple more examples and then we'll do some that are a little bit harder. So in our next example, now we've got 6 and 5. Those are what we call constant terms. Constant terms cannot be combined other than multiplication, addition, etc. So in this case, we happen to be multiplying. So we're going to multiply 6 and 5. 6 times 5 is 30. Then we have z squared and z squared. Again, bases are the same. So we add the exponents. 2 plus 2 gives me 4. Letter D is a little bit trickier. So I'm going to write this out. I see that I've got an n in here, so I'm going to write that out with my exponent. So negative 3 times n to the 1st times y to the 4th times negative 9 times n cubed. So again, let's start. We can only combine like terms. Constant terms, negative 3 times negative 9 gives me a positive 27. But then we can only combine like terms with our variables as well. So I can only combine n's. Bases are the same, we're multiplying, so we add the exponents. 1 plus 3 gives me 4. Now unfortunately, my poor little y to the 4th has nothing to combine with, and so therefore it stays y to the 4th. So now that's monomial times monomial, a single term times a single term. Single term, single term. Now we're going to multiply a monomial and a binomial. Monomial again is a single term, binomial 2 terms. Trinomial, 3 terms. Polynomial is multiple. Anytime we get above 3 terms, we generally refer to it as a polynomial. So when we multiply a polynomial by a monomial, we must distribute. We're going to use the distributive property. So we're going to use the we must distribute. Whoops, I should have written distribute. There we go. Little typo, that's okay. All right, so let's take a look. We're going to start with our first basic one. We've seen problems like this before, where we have a constant term, a plain old number in front, and then either 2 or 3 terms that are added or subtracted next to it. That's our polynomial. This specifically would be a trinomial. There's 3 terms. So we have to distribute. I essentially have to go -2 times every single term in the trinomial. So I'm going to do -2 times x squared will give me a -2x squared. -2 times -3x. So we're going to multiply those constant terms together. -2 times -3 is +6, and the x stays unchanged. And then we have a constant term. -2 times +1 gives me -2. Where it gets interesting, though, is when we start distributing variables. So in letter B, you can see we're distributing an a. So again, a gets multiplied by both terms of my binomial. So we have to do a times a and a times 4. So let me write that out so we can see that. A times a. Now, if I do a times a, that's going to give me, and then we're going to have a times 4. So a times a, again, think about our rules. If we're multiplying and the bases are the same, we add the exponents. So that will give me a squared. However, in our second part, a times 4, they're not like terms, so we're not going to add bases or anything of that nature. I'm just going to write it as 4a. Okay. Let's look at our third example, letter C. So again, we're multiplying x this time, and again, x gets multiplied by both parts of my binomial. So I have an x times a 4x plus an x times an x cubed y. So again, remembering that exponents, when they're not written and not shown, they are 1. I'll just put these in. So x times x, bases are the same. We add the exponents. So I end up with 4x squared. In the second term, x to the first, x cubed, bases are the same. We're multiplying, we add those exponents. We get x to the 4th. Y cannot be combined, so we leave it as y to the 1st or y. Now, it's always a good idea to see if there's any combining of like terms that need to happen. After multiplying, look through your work to see if there are like terms to combine. So let's do a couple of those examples. Let's look at our first one. X times this trinomial. So again, I'm going to multiply x times every term of that trinomial. So x times 2x plus x times 1 plus x times -4. So again, our exponents here, this will give me 2x squared plus x, multiplying, minus 4x. But I do have some like terms. I have some x's, so let's combine like terms. If I have an x and I take 4 x's away, I'm now down to negative 3x. Let's look at our last example. A squared times a times 2a times 3. So let's go ahead and combine like terms and multiply. A squared times a squared times 2a, and a squared times 3. So again, put the ones in for the exponents that aren't written. So we're left with a cubed plus 2a cubed plus 3a squared. Now I have some like terms to combine. So that gives me 3a cubed plus 3a squared.